Hi third graders, it's Mrs. Burke, and today we're going to be working on a lesson that's going to show us how we can divide shapes into parts with an equal area. Each part will have the same area. And once we do this, we're then going to write the area as a unit fraction of the whole. So a couple of things to review before we get started. What is area? Area is going to measure the amount of space inside a figure. So we're not going to be looking at the outside, which would be the perimeter of it. We're just going to focus on the amount of space that these objects take up on the inside. Next, we also want to remember what a unit fraction is. A unit fraction is any fraction that has a numerator with 1. So 1/2 is a unit fraction. 1/10 would be a unit fraction. 1/5 is also a unit fraction. A fraction like 3/4 would not be a unit fraction because that numerator is not the 1, okay? So for today's lesson, we're going to be cutting apart shapes that we're familiar with, plane shape figures, and we're going to be trying our best to divide it up into equal parts. So let's take a look at our first example, which is a hexagon. So in this hexagon here, right now, we would call this hexagon one whole because it is not broken up into any smaller parts. There is just one large piece, which would be one whole. However, we can break it up into smaller equal parts. For example, I could break this fraction up into 3 equal parts, and it would look something like this. One part, the purple would be the new part. 2 parts, 3 parts. So all 3 of these are rhombuses, which when put together, they make up my whole. Since these 3 parts are equal, I'm allowed to give them a unit fraction of 1/3. It took 3 of these parts to equal the whole. So altogether, this whole would be made up of 3/3. Here's 1 of the thirds, 2 of the thirds, 3 of the thirds. So altogether, it would be a fraction with 3/3 in it. Now, let me go back to my whole. And this time, let me try to break it into 6 equal pieces. I can do that by cutting it into smaller triangles. So right now I have 3 triangles, 4, 5, 6 triangles. And as you can see, when I split my whole hexagon into 6 equal parts, they turn into smaller triangles. What unit fraction do you think I can give to each of these triangular parts? I can give it the unit fraction 1/6. Because each triangle is one of the 6 parts that makes up the whole. Now when I add up 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, all together, I will have 6/6. And these are equivalent because when I have all of these pieces on my hexagon, it makes up the one whole. Let me try to split it one more way. I'm going to split it in half. So I can do that by just going right across. And when I split it in half, I see 2 trapezoids, right? So this is one of the 2 pieces, and this is one of the 2 pieces. So I could also split it into 2 halves with these unit fractions. All of these still equate to the same area. It's the same amount of space that was taken up on the inside. Even though they're different size parts, the halves, the thirds, and the sixths, they still take up the whole hexagon, so they share a common area. Now let's look at something on a grid. So let's first look, sorry, let me just adjust this. Okay, Let's take a look here at these two rectangles on the top. Hopefully I have enough room. Okay, the two on the top we're gonna focus on here. Now, they both are the same size, and I know that because the boxes and the grids prove it to me. I have 3, 6, 9, 12, 15, 18 in here. 3, 6, 9, 12, 15, 18 here. First, let me break them up into 6 equal parts over here. So I could do 1/6, another 6, another 6, another 6, another 6, and then another 6. Now this is a little tricky because the reason I'm giving it the unit fraction of 1/6 is because it takes 6 of these pieces to cover the whole rectangle. However, each one of these 6 is made up of 3 boxes, but it doesn't make it a third. It's still one of 6 pieces. The pieces just happen to be 3 boxes big. And for this one, you can see that each 6th is the same area. They're all 3 boxes, but they're also the same exact shape. I have 6 rectangles here. Now watch what I'm gonna do over here. I'm gonna make 6 equal pieces. So this will be 1/6. I'll write it this way. This will be 1/6. This will be 1/6. Then maybe I'm gonna do these 3 will be a 6th here. Then I'll do these 3 will be a 6th here, and those 3 will be a 6th there. Now the interesting thing about this is I still have 6 pieces. Are they equal is the question. And the answer is yes, because they take up the same amount of area. This piece here is made up of an area of 3 boxes. This over here is also made up of an area of 3 boxes. This piece here is made up of an area of 3 boxes. So they all have the same area, so they're equal parts, equal pieces. The only thing that's different is they're not the same shape. So this is like a rectangle, a rectangle, a rectangle, but this one here is like an L shape. So they're not the same shape, but they are the same area because they take up the same number of boxes. So these parts are still 1/6 to give us a total at the end of the 6/6 of the whole. All right, let's look over here. I have a figure and I want to show 2 equal parts. Well, let me see how many boxes I'm working with to begin with. I have 3, 6, 9, 12, 15, 18, 19, 20. If I wanted to make 2 equal parts, it doesn't mean they have to be the exact same shape. It just means they have to cover the same amount of area. So if I have 20 boxes and I want them split into 2 equal parts, it means each part will have to have an area of 10 boxes. So watch how I do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could do it like this, right? So I have 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And what would we call each piece? They're not 1/10. Their area is 10 boxes. But the unit fraction here, my whole was split into 2 equal parts. So each one is one of the 2 equal parts. And altogether, it's 2 halves or a whole. Okay, so don't mix up the unit fraction with the area that you're including in each unit fraction. Let's look at this next one. 4 equal parts it's going to be split into. Well, let me see what I'm working with to start. 2, 4, 6, 8, 10, 12, 14, 16 units are in there. So if I want to split 16 units into 4 equal parts, each one of my unit fraction is going to have 4 square units in it. So let me try. This can be one of them. This can be one. This can be one. These happen to all be the same exact shape. But what's more important is, are they the same area? Well, this has 4 boxes, this has 4 boxes, this has 4 boxes, and this has 4 boxes. And coincidentally, since there's a total of 4 parts I just made, they are going to be called fourths. Not because their area inside is 4 boxes, but because it took 4 of these equal sized boxes to cover the whole. Let me try it one other way, where it's not going to look like the same shape everywhere. So I can do 1, 2, 3, 4 up top. Then I'll do 1, 2, 3, 4 over here. Then I'll do 4 over here. And then this box over here. So for this configuration, I have 4 boxes making my area, but they're not the same shape. But it's okay because they cover the same amount of area, and that's what I'm looking for. So this will be 1/4, 1/4, 1/4, and 1/4, and all together I have 4/4. Okay, so try those out today. Try some that have similar shapes, like this. And then see if you can also do some configurations that you might not be making the same shape, but you're guaranteeing and making sure that they all share the same area. Okay, good luck today, and I'll see you soon. Have a great day, Stuart.